This is Mrs. Zappia with Lesson 8 from Module 3, using if-then moves in solving equations. Student outcomes for this lesson. Students understand and use the addition, subtraction, multiplication, division, and substitution properties of equality to solve word problems, leading to equations of the form px plus q equals r, and p times the quantity x plus q equals r, where p, q, and r are specific rational numbers. Students understand that any equation with rational coefficients can be written as an equation with expressions that involve only integer coefficients by multiplying both sides by the least common multiple of all the rational number terms. The intent of this lesson is for students to make the transition from an arithmetic approach of solving a word problem to an algebraic approach of solving the same problem. The essential question is, how do you make zeros and ones with equations and for what purpose? Recall and summarize if-then moves. If a number is added, subtracted, multiplied, or divided from both sides of an equation, then the equation remains equal. For example, if A is equal to B originally, then if you add C to both sides of the equation, it remains equal. If A or B is equal and you subtract C from both sides of the equation, the equation remains equal. If A is equal to B and you multiply both sides of the equation by C, then the equation remains equal. If A is equal to B and you divide both sides of the equation by C, the equation remains equal. So the thing to remember here is that whatever you do to one side of an equation, you have to do the same thing with the same number on the other side of the equation. Write 3 plus 5 equals 8 in as many true equations as you can using the if-then moves. Identify which if-then move you used. If 3 plus 5 equals 8, then 3 plus 5, and what we're going to do is we're going to use the addition property of equality, and we're going to add 4 to both sides of the equation. Now, the left side of the equation and the right side of the equation are still equal because 3 plus 5 plus 4 equals 12 and 8 plus 4 equals 12. So if they are equal to begin with and you add the same number to do the same operation on the left and the right side of the equation, then they will remain equal. If 3 plus 5 equals 8, you can use the subtraction property of equality and subtract 4 from both sides of the equation, and they will remain equal. So 3 plus 5 minus 4 is 4, and 8 minus 4 is 4, and that's the subtraction property of equality. We can also use this with multiplication. Multiply both sides of the equation by a number, and we'll keep using 4. 4 times 8 is 32. 3 plus 5 is 8 times 4 is 32. So the equation remains equal. And finally, with division. If they're equal to begin with and you divide by the same number, the equation will remain true. So 3 plus 5 divided by 4 and 8 divided by 4. 8 divided by 4 is 2. 3 plus 5 is 8. 8 divided by 4 is 2. They remain equal. To solve a linear equation, now this isn't in your notes, but I wanted to go through it with you. A linear equation is an equation that contains a single variable, usually x, raised to the first power. Solving linear equations, remember to first simplify each side of the equation, and to do that, you're going to go according to PEMDAS. So parentheses first, then exponents. Multiplication and division left to right before adding and subtracting left to right. Then you see the O at the end, so now the word is PEMDASO. And the O means when you are solving for the variable to go in the opposite direction using the opposite operation. So when you're ready to solve, you're going to first undo any addition and subtraction using the opposite operation. So if the equation says to add, you will subtract. If the equation says to subtract, you will add. Then you will undo any multiplication and division. And if it says to multiply, you will divide. If it says to divide, you will multiply. For right now, that's as far as we're going to go with solving equations. Julia, Keller, and Israel are volunteer firefighters. On Saturday, the volunteer fire department held its annual coin drop fundraiser at a streetlight. After 1 hour, Keller had collected $42.50 more than Julia. Israel collected 15 less than Keller. The three firefighters collected $125.95 in total. How much did each person collect? What you want to notice here is that you know nothing about Julia's collection, but they compare Keller's and Israel collections to Julia's. So Julia is our complete unknown. So we'll start with using a tape diagram and a variable for Julia. So in terms of Julia, this will be her amount that she has collected. And then it says that Keller collected $42.50 more than her. So we'll let this box represent Julia's, and then this will represent the $42.50 more that Keller collected. So we'll go ahead and write $42.50 in that. Then Israel collected 15 less than Keller. So that means he collected 15 less than this amount. So if we take $15 off of the $42.50, then that will be Israel's amount. So let's go ahead and start with that. And then the $42.50, take away the $15 is going to be Israel's amount. So you can see that Israel's amount is less than Keller's. So if we have $42.50 and we take away the $15 because he collected 15 less, that leaves us with $27.50. So Israel collected this amount. So Julia collected this amount, which is completely unknown. Keller collected $42.50 more than that, and then Israel collected $15 less than Keller. And we know that the total of all of these is $125.95. So we're going to go ahead and make our tape diagram. And we know that this will be Julia's amount, and then this will be Keller's amount, and then we have Israel's amount. So here's our complete tape diagram, and we know that this total is $125.95. Then what we want to do is representing here, we have 1, 2, 3 units, and we have $42.50, and we also have $27.50. So we have 3 units plus $42.50 plus $27.50. So now let's reorder our units so that they're like. So we have 3 of these units, so we'll put these 3 together, and that represents this unit, and this unit. And then we also have one of these, that's the $42.50, and one of these, which is the $27.50. So all I've done is I've reorganized to put our 3 units together and then the money together. Now, the money together equals $70, and these are the 3 units. So if we know that the whole amount is $125.95 and we take away the $70, then we'll know how much these 3 units represent. So $125.95. Take away the $70, and that leaves us with $55.95. Then that $55.95 can be split evenly between these 3 units, and that will tell us how much one of these units is worth. So $55.95 divided by 3 is equal to $18.65. So 1 unit is equal to $18.65. What were the operations we used to get our answers? We added $42.50 and $27.50 to get 70. We subtracted 70 from $125.95 to get $55.95, and we divided $55.95 by 3 to get $18.65. The amount of money Julia collected is J dollars. Write an expression to represent the amount of money Keller collected in dollars. So we know that Julia is J and Keller was $42.50 more than that. So we have J plus $42.50, and that represents Keller's amount. And we know Julia is J. Then, using the expression for Julia and Keller, write an expression to represent the amount of money Israel collected in dollars. So Israel collected J plus $42.50, but it said that he collected 15 less than Keller. So now we want to subtract $15. So Israel's expression is J plus $27. Using the expression written above, write an equation in terms of J that can be used to find the amount each person collected. So here we're going to put the expressions together into an equation. So we have Julia's amount, plus we have Keller's amount, which is J plus $42.50, and we have Israel's amount, which is J plus 27. So those are the three expressions for the three people, and we know that that equals a total of $125.95. So notice that these are expressions. They do not have equal signs, but they represent how much money the people collected. And once you know the total that they collected, you can write the equation. So we have each single person, what they collected, and it adds up, and it equals $125.95. So while this is just an expression, once you add the equal sign and the amount that it's equal to, now it is an equation. Solve the equation written to determine the amount of money each person collected and describe any if-then moves you used. So our equation is J plus $42.50 plus J plus $27.50 equals $125.95. So we've got our equation, and remember to use PEMDASO. So we're going to simplify first, following the order of operations on PEMDAS. And we have all addition, so we can do this in any order, any grouping. So the first thing I'm going to do is I'm going to collect my like terms. And I have J plus J plus J plus $42.50 plus 27. And that's equal to $125.95. Now, combining my like terms, that's 3J, and then I'm also going to add the $42.50 and the $27. So I have 3J plus $70 equals $125.95. So I've simplified everything I can. Now I'm going to solve my equation. I'm going to go in the opposite direction, undoing the math. So first I'm going to undo any addition and subtraction. So I'm going to undo this addition with subtraction. Subtract 70 from both sides using an if-then statement. So if it is equal to begin with and I subtract 70 from both sides, then it remains equal. It's not a bad idea to draw a wall in between the sides to make sure that you're doing the same thing with the same number on the left and the right. So here we have a positive 70 and a negative 70, and that equals a zero pair. And 3J plus 0 is 3J. And 125 minus 70 is the 55.95. And you might recognize this from the previous page where we had 55.95 that we split up between the three units. So now 3J means to multiply. We're undoing multiplication and division. You do the opposite operation. The opposite of multiplying is dividing. Show division with a fraction bar, and we're going to divide by the coefficient. The purpose of this is to get 1J. So 3 divided by 3 is 1, and 1 times J is J. 55.95 divided by 3 is 1865. So what that means is that Julia earned $18.65, and Keller earned $42.50 more than that, so we have $18.65 plus $42.50 for Keller. And then Israel earned J plus 27, which is $18.65 plus $27. So the three amounts that they earned, Julia earned $18.65, Keller earned $61.15, and Israel earned $46.15. And those three amounts add up to $125.95. Recall the essential question about making zeros and ones and to what purpose. So here is where we made a zero, and that was to get rid of the constant to isolate the variable. And then when we divide by the coefficient, that's going to give us 1, and the purpose of getting a 1 is to get just one variable, so you know what 1 unit is equal to. And we did that using if-then statements. The if-then statement that we used here was to subtract 70 from both sides, and here we used the division property of equality to divide by 3 on both sides of the equation. In example 2, you are designing a rectangular pet pen for your new baby puppy. You have 30 feet of fence barrier. You decide that you would like the length to be 6 1/3 feet longer than the width. Draw and label a diagram to represent the pet pen. Write the expressions to represent the width and the length of the pet pen. So it's always a good idea to draw a diagram to help you solve and set up a word problem. So we know that it's going to be rectangular, and we know that the length is going to be longer than the width. And it says that it's going to be 6 1/3 feet longer. So what we want to do is, we know nothing about the width, but we know that the length is going to be 6 1/3 feet longer. Since you know nothing about the width, that is your unknown, so that is your variable. So we'll use W for width, and on a rectangle, opposite sides are the same length, so we'll label that as W as well. Then the length, which is the longer side, is 6 1/3 feet longer than that. So whatever the width is, we have to add another 6 1/3 feet to that. So the length is W plus 6 1/3. And we'll go ahead and label all 4 sides. Now the perimeter is 30 feet, and we know that the perimeter is when you add all 4 sides together. Now let's go ahead and write our width is equal to W, and our length is equal to W plus 6 1/3. Now the perimeter, we're going to go ahead and solve this problem arithmetic and the algebraic method. So first let's go ahead and solve it with arithmetic. We know that the perimeter going all the way around is 30 feet, so that's what we're going to start with. Then we're going to take away the 6 1/3 feet from both sides. So let's say that the 6 1/3 feet is about this much. We're going to take that away from the 30 feet and see what is left over. So minus 6 1/3 and minus 6 1/3. And that gives us a total of 17 1/3 feet left over for the width, which is these sections. Then we want to take that 17 1/3, and to find out how much one of these sections is worth, notice that they're all the same length, we're going to divide that into the 4 sections. So that is going to leave us with 4 1/3. 17 1/3 divided by 4 is 4 1/3. And that means that the width is 4 1/3 feet. So this section is 4 1/3, this is 4 1/3, 4 1/3, and 4 1/3. And then all of these together, if we add another 6 1/3 and a 6 1/3, all of those together will equal the 30 feet. So the length then is the 4 1/3 plus the 6 1/3. Looking at the diagram, you've got the 6 1/3 right here, and then you've got the 4 1/3 here. So add those together to get the length, and that's going to give you 10 2/3 feet. So now we know the dimensions of the pen. The width is 4 1/3, and the length is 10 2/3. Now we're going to solve the problem with algebra. We know that the perimeter is adding all of the sides together. There are several different ways to find the perimeter. We're going to use addition. So we're going to add the width plus the length, which is W plus 6 1/3, plus the width plus the length, which is W plus 6 1/3. And we know that that is equal to 30. Now we're going to reorganize. All of this is addition. Since it's all addition, we can drop the parentheses and use any order, any grouping, which is a combination of the commutative and associative properties of addition. So we'll group our like terms. We have W plus W plus W plus W plus 6 1/3 plus 6 1/3. And all of that together equals the perimeter of 30. Now combine your like terms. We've got 4W because repeated addition is multiplication. Then combine your 6 1/3, and that gives you 12 2/3. And together that equals the perimeter of 30. Now we've got an equation in the form of Px plus Q equals R. Then we need to follow PEMDASO. And notice that we've already done the PEMDAS. PEMDAS is simplifying, and we did the addition for PEMDAS. Now, when you're ready to solve the equation, you're going the opposite direction, undoing addition and subtraction first, using the opposite operation. So the opposite of adding is subtracting. We're going to subtract 12 2/3 from both sides of the equation. This is an if-then statement. If it's equal to begin with, and you do the same thing with the same operation on both sides of the equation, it remains equal. So here's our zero pair, and that will get rid of the constant. 4W is left on the left, and then 30 minus 12 2/3, you do need to borrow 29 3/3, and you subtract this and you get 17 1/3, and you see that's what you had over here. Now, using an if-then statement, if these are equal to begin with and you divide by the same number on both sides of the equation, it will remain equal. So we want to divide by the coefficient. The purpose to that is to get 1 with a variable, because 1 times W is W. Then 17 1/3 divided by 4 is 4 1/3 feet. And that tells you the width of the rectangle. And then your length, again, you just add, the length was W plus 6 1/3, substitute the 4 1/3 that we found for the width, add the 6 1/3, and that gives you a length of 10 2/3. So we have found the dimensions. Remember that dimensions mean length and width when it comes to a rectangle. We're going to skip this question and go to the next page. For example 4. The total number of participants who went to the 7th grade field trip to the National Science Museum consisted of all 7th grade students and 7 adult chaperones. 2/3 of the total participants rode a large bus, the rest rode a smaller bus. 54 of them rode the large bus. How many students went on the field trip? So we're going to solve this using an arithmetic and an algebraic approach. The reason for this is because the purpose for this assignment is to start making the transition from arithmetic to using algebra. So let's draw a diagram using a tape, and we have a large bus and a small bus, and we know that 2/3 of the participants rode the large bus. So this will be our large bus, and then this will be our small bus, and here 2/3 of the participants. So the entire tape diagram represents all of the participants, and then this 2/3 represents the large bus, and this 1/3 represents the small bus. And we know that 2/3 of the participants rode this bus, and we know that that number is 54. So we have 54 taking up these two sections, and we want to know how many students or how many participants were in one of the sections. So 54 divided by 2 equals 27. And that means that there were 27 in this section, 27 in this section, and 27 in this section, because they are all the same size. So 27 plus 27 plus 27, or you can use multiplication instead of repeated addition, and that equals 81. And that's the total. So the question was how many students? 81 total. Take away 7 chaperones equals 74 students. Let's solve the problem using an algebraic approach. And I'm actually going to show you two different ways to do this. So if you draw a line down here, and here's what we know. We know that 2/3 of the participants, 2/3 of the total participants rode the large bus. And we know that the participants make up the students and the chaperones. And we don't know the number of students, so we'll use a variable for S. We know that the number of chaperones is 7. And we know that 2/3 of the total participants is 54 on the large bus. So we're going to solve this problem two different ways. Let's write the problem on the right side as well. 2/3 times the quantity S plus 7 equals 54. And then you can decide which way you prefer to do this. So the first way I want to solve this is to distribute the 2/3 to the first and the second term in the parentheses. And that's going to give us 2/3 S plus 2/3 of 7 equals 54. 2/3 of S, oops, let's rewrite that neatly. Two-thirds of S. And then here, let's multiply that out. That's 7 over 1, so that's 14/3. And that's equal to 54. Now remember, we're following PEMDAS. And PEMDAS, we're simplifying, following the order of operations. And we did that when we did the distributive property. And then here, where we multiplied 2/3 times 7, we're done with PEMDAS. We're done with all the simplifying we can. So now we're ready to solve the problem. When you solve the problem, remember to go in the opposite direction, undoing all addition and subtraction first. So we're going to undo this addition with subtraction. And we're going to subtract 14/3. Remember, you have to do the same thing with the same number on both sides of the equation. And simplify. The 14/3 and the negative 14/3, that equals a 0 pair. And 0 plus 2/3 S is 2/3 S. And 54 minus 14/3 is 49 1/3. Next, we have 2/3 times S. The opposite of multiplying is dividing. So we're going to divide both sides by 2/3. Remember, when you divide by a fraction, that you are actually multiplying by the reciprocal. So I'm just going to take this and show you on a different page what that would look like. We'll come back to that page. So here we have 2/3 S is equal to 49 1/3. And I'm going to divide by 2/3. A number divided by itself is 1. and 49 and a third divided by 2/3 is equal to 74. So here we have 1 times s, and that equals s. So s is equal to 74. And as I said over here, when you are dividing by a fraction, that's the same as multiplying by the reciprocal. So we could also have written this as multiplying by the reciprocal instead of dividing. So it would look like that, where you're multiplying by the reciprocal, because 2 and 2 equals 1, and 3 divided by 3 equals 1, and 1 times s is s. So we could also write that as multiplying by the reciprocal instead of dividing. So we get down to our answer, and we have 74 students on the trip. Now, there is an easier way to solve this problem, so let's take a look at it over here. One of the things that made this problem difficult was that you had to distribute the 2/3. And we can avoid doing that by undoing this multiplication. Instead of multiplying each item by 2/3, we can divide both sides of the equation at this time by 2/3. So again, in order to show division of a fraction, multiply by the reciprocal. So the reciprocal is 3/2, and the reciprocal is 3/2. Again, instead of dividing both sides by 2/3, we're going to multiply by the reciprocal. So here the 2's cancel each other out because 2 divided by 2 is 1. The 3's cancel each other out because 3 divided by 3 is 1. So now we have 1 times the quantity, s plus 7, which is s plus 7. And over here, 54 times 3/2. So here this is 54 over 1. And we can cancel with the 2's, divide by 2, that gives us 1, divide by 2, that gives us 27. And 27 times 3 is 81. 81 divided by 1 is 81. Now undo the addition with subtraction. This gives us a 0 pair, leaving with the variable s, which stands for students, and 81 minus 7 is 74. So we have 74 students that went on the trip. So we did this problem 2 different ways. Here, instead of using the distributive property to multiply by 2/3, instead we divided by 2/3. So we just did the problem in a different order, but got the same answer. In this lesson, you learned an algebraic approach, which is to solve an equation algebraically, means to use the properties of operations and if-then moves to simplify the equation into a form where the solution is easily recognizable. For the equations we are studying this year, called linear equations, they form an equation that looks like x equals a number, where the number is the solution. So again, this is the solution. If-then moves. If x is a solution to the equation, it will continue to be a solution to the new equation formed by adding or subtracting a number from both sides of the equation. It will also continue to be a solution when both sides of the equation are multiplied or divided by a non-zero number. We use if-then moves to make zeros and ones in ways that simplify the original equation. So here's the example of making a 0, and we do that to eliminate the constants. And then to make a 1, that's where we either multiply by the reciprocal or divide by the coefficient. And when you do the same thing with the same number on both sides of the equation, that's the if-then move. Finally, a useful first tip. If one is faced with the task of finding a solution to an equation, a useful first step is to collect like terms on each side of the equation. So remember to use PEMDAS to simplify the equation. PEMDASO, that means when you're ready to solve the equation that you go in the opposite direction with the opposite operation, undoing any addition and subtraction first.